come back over here. All right, so I'm on black, so I'm going to change that up. Pardon me, guys. Go over here and turn this thing blue. All right, so 155. Let's see, where's 155 going to end up? It's going to end up in there. 142, it's going to end up in there. 149 is going to end up in here. 130, if you catch me making an error, there's nothing you can do about it. 151, just kidding, right here. 163, that goes right here. 151 goes right there. 142 goes right there. 156, speaking of garbage in, garbage out, right? 133, that's going to be right here. See how it's on the boundary line, but because it's intense, I don't have to worry about it. 138 goes right there. 161 goes right there. 128, there's 128 right there. 144 goes right there. 172, it's way up here with this guy. Oops. 137 right there. 151, 166, 66 gets me there. 147, 147 is here. 163, I got to be careful. It's starting to get a little punchy. 145, 116, 136, 158, 114, whoops, 114, 165. If you're bored as heck, you can always fast forward through this. 169 right here as well. And then 145, which is right here. Okay? Now, let's see what we got. What I'm going to do, and the reason that this is called a frequency distribution is because we then write down the frequencies, which is typically written as f. So for this guy it's 2, for this guy it's 3, for this guy it's 5, this appears to be 8, this is 6, and this is 4. Let's see what I got here. I got 10, I got 28. Hey, look at that. N equals 28. That's kind of cool, huh? All right, now, sometimes the way that you'll see this written is, excuse me, the way that you'll see this written as it's written with midpoints. So you'll sometimes see this written as x sub n, or you'll see it this m implies midpoints, or you'll see it written as midpoints. So we can simplify this whole thing that I have here into just this easy peasy little deal. All right, so to find the midpoint of that, I simply have to add 5 to this, and that gets me to the midpoint, right? You agree? So this would be 118.5. Let's see, 128. It's easy to figure these out because once I have the first one, I can just add the class width to get to the next one. Does that make sense? You can't respond. 148.5, 158.5, and then 168.5. And then you'll see it written with 2, 3, 5, 8, 6, whoops, 6, and 4. That's supposed to be a 6, and with n equals 28. Now, the rationale behind writing these with midpoints is that in theory, statistically speaking, all of the data values in each one of these classes are going to cluster around the middle of the class. Now, whether that happens or not, it doesn't really matter. But I do want to show you the power of a frequency distribution. Check this out. If I think about this, if you take your head and you twist it to the right, look at what I have. I have this very cool distribution now. This thing looks like, it kind of looks in a very rudimentary form. It looks like one of these guys, doesn't it? So I can start thinking to myself, if I could turn this thing horizontally, if only there were a graph that I could use in statistics. Well, I'll teach you one of those here in just a sec. If I look at this thing, it's like, oh, graphically speaking, I can already see that this thing's going to have a shape. Whoops, I did a little writing there, didn't I? When I graph this thing, its distribution is going to look like that. Doesn't appear to be any outliers. My center is going to be somewhere in here, which is exactly where you would expect. let's see, our variation is really easy to figure out. I go from about 113.5 to about 173.5, and we're all good. I'm going to try and erase my strange move over here, which you guys all wanted to tell me I screwed up on, and you couldn't. So that is a frequency distribution in a nutshell. We will get into some more tricky ways to deal with these frequency distributions down the road. I'm going to give you guys a little break and let you walk away from this for a little while, and then when I see you, we'll come back and we'll get a little more information from our frequency distribution. It's a really super powerful little chart that we can use to really organize our data, and then we get to start presenting our data and start making decisions based on what we see. All right, thanks for your attention, and have a really good day. Welcome back, everybody. I hope you all had a nice break. Hopefully you didn't get too many wet willies this thing happens. So we're going to do a little more work with our frequency distribution here really quickly, and then we'll be done for this little lesson. We'll get into some more graphs in the next lesson. Okay, so remember, this was our data. We took our data, we went through, found the class width, we built our classes, and we just used our tallies by crossing out the data as we went. We created class boundaries or class widths. It can be written either way. And then with our frequencies, we can clean it up with our midpoint right here. Remember, this guy right here is our midpoint of each one of these classes. So there's lots of ways to do that. Now we're gonna have a little bit more fun with this because we can get a lot more information out of a really simple little distribution here. But I need a little more room. So over here on this page, I did a little erasing. I'm going to do something called relative frequency and cumulative frequency. So I might also do a cumulative relative frequency, but that just seems silly. All the cumulative frequency is I'm going to write it as a new column, so I'm going to have CF, and I'm going to write a 2 here because the first class has 2, and then all I do to fill out the chart is I write out for each one of the widths how many of the total. Remember, down here n equals 28, that's how big our sample was. I'm going to write these out as they accumulate. So when I go to my second width, I pick up the 2 from the first, the 3 from the second, so this guy's a 5. All I'm doing basically is adding this to get this. All right? Now, for this guy, I have 2 plus 3 plus 5, and I get 10. Really, think about it this way. I add this guy to get 5. I add 5 to 5 to get 10. I'm going to add 10 to 8 to get 18. So this class right here picks up 18 plus 6, which is 24, and then 24 plus 24 is 28. It's nice because this number should always equal the total in n. Okay? So basically what that tells us is how much of the classes, for any given class, how many data values are at that class or behind. And we'll use that a lot more down the road with something called percentiles, but we'll get to that when we get to it. The other thing is we're going to talk about relative frequency. So we're going to do RFs. I should probably write that down. CF equals cumulative frequency, and RF equals relative frequency. All right, and all the relative frequency is it's the frequency of that specific class relative to the others, to the total. Excuse me. So what we end up with is a percentage. So the relative frequency for the first class is 2/28, which is 1/14. Let's see. I'm cheating, you guys. I hope you don't disrespect me. So about this is about 7%. So 0.07. All right, this guy's going to be 5/28. 5/28 is about 18%, so 0.18. I can write this as a percent if I wanted to. This is going to be 10/28, which is 36%. You got to be a little bit careful here because you're going to have to give up a percent somewhere, because remember, they all got to add up to 100% when everything's said and done. Wait a sec, I screwed that up, didn't I? I don't want 5 and 18. Excuse me. Try that again. That would be the cumulative relative frequency. Let's try that again. This one's going to be 3/28. It's good to see your instructor make mistakes. Let's see, 3/28. So that's going to give me about 11%. So 0.11. 5/28 is about 18%. So I guess I wrote that earlier, didn't I? 8/28 is about 29%. Again, I'm going to have to give up a point here at some point, but I'm not afraid. 6/28 is 21%. And then if I needed to, let's see, that's going to be 18, 36, 65, 86. So this guy should be about 0.14. Let me check it for, yeah, 1/7, right? 0.14. And I know that this sums to 100% or 1. If I wanted to do the cumulative relative frequency, that'd be the CRF. This is kind of useful for percentiles. I just add them up. So same way as we did before. This would be 0.07. I go from here to here. I get 0.18. Go from here to here. Excuse me. I get 0.65 and then 0.86. And then hush my mouth, I get 1.0, which is the same thing as 100%. Okay, so that's about as much as you can do with the frequency distribution as far as being useful and giving us some data that we can play with down the road. In the next lesson, what we're going to do is we're going to take these frequency distributions and we're going to put them on graphs. Some graphs lend themselves really nicely to frequency distributions, others not so much, but I'm just going to give you some examples of some graphs, and then we'll be done. All right? Hope you enjoyed the presentation. Have a great day.